Let's go over the solutions to functions part 2 exercises. So let's look at the functions f of x equals 2x squared plus 3 and g of x equals 4x minus 8, and we'll evaluate the following. So at first we'll do f plus g at 4. So remember, when you take f plus g of x, that would be f at x plus g at x. Well, here we're doing it for a specific x value, so this is going to be f evaluated at 4 plus g evaluated at 4. So doing our function evaluation, into f I will substitute x with 4, and into g I will substitute x with 4. Now, when you're doing your function evaluation, I highly recommend that you keep it all in parentheses. So here's my f at 4 in parentheses, here's my g at 4 in parentheses. And then evaluate, simplify, so parentheses first, right, for order of operations. That gives me 2 times 16 plus 3. This gives me 16 minus 8. 2 times 16 is 32 plus 3 is 35. 16 minus 8 is 8. And now I can add those two numbers together to get 43. Now let's look at g minus f at negative 3. So what that's asking me to do, remember g minus f at x would be g of x minus f of x. But I'm not doing it for the general x. I'm doing it for the specific x negative 3. So that's going to be g evaluated at negative 3 minus f evaluated at negative 3. So here's my g at negative 3, replacing x with negative 3. Here's my f at negative 3, replacing x with negative 3, but I keep them both in parentheses and subtract here. That tells you that you need to evaluate the function first. You need to figure out what is g at negative 3 first, figure out what f at negative 3 is next, then subtract the two. So to make sure that you are solving, you are evaluating the functions first, we stick them in parentheses. 4 times negative 3 is 12. Negative 3 squared is 9. Negative 12 minus 8 gives me negative 20. 2 times 9 is 18 plus 3 gives me 21. And negative 20 minus 21 gives me negative 41. F times g at negative 2. So again, we talked about how f times g at x would be f of x times g of x. Well, here what I want you to do is take f and evaluate it at negative 2, get a value. Take g evaluated at negative 2, get a value, and then multiply those two together. So here's f at negative 2, all in parentheses, g at negative 2, all in parentheses, and then I'll multiply those two values together at the end. So that's going to give me 2 times 4 plus 3 times negative 8 times minus 8. That gives me 11 times negative 16, or negative 176. F over g at 2. So f over g at x meant take f of x, divide that by g of x, but here we're doing it for the specific x2, so I want f evaluated at 2, and I want g evaluated at 2, then I want you to divide those two numbers. So f evaluated at 2 on the top, g evaluated at 2 on the bottom. That gives me 2 times 4 plus 3 over 8 minus 8. 2 times 4 is 8 plus 3 is 11 over 0. Now remember, you can't divide by 0. That is not defined in the real number system. We don't know what it means to take 11 cookies and divide them amongst 11 people, or 0 people. What does it mean to take 11 and divide it into 0 groups? Where do they go? If the cookies just stay on the table, well then they're in one group, right? A group of 11. So how do you take 11 cookies and divide them into 0 groups? We don't know how to do that, so we say that's undefined. Let's visit that composition function again, f composed with g of x. That means we're going to do f of g of x. So into f, we're going to plug in the entire g function, which I'll remind you was 4x minus 8. So f takes 2 times your input squared plus 3. It's just my input is that whole function 4x minus 8. So I'm going to take this 4x minus 8 and square it. I've got subtraction. I can't distribute the exponent, so that is 4x minus 8 times 4x minus 8. I'll distribute this out. I'll go ahead and do my 4x minus 8 times 4x minus 8 first. 4x times 4x is 16x squared, minus 32x plus 64, plus 3 at the end. Combine my like terms inside here, and now I'll distribute the 2, combine my like terms on the outside here, and I get 32x squared minus 128x plus 131. Now, the other thing that we can do is we can do g composed with f of x, which means g of f of x, which means into g I'm going to plug the entire f function, which is 2x squared plus 3. So look at what g does. G does 4 times your input minus 8. It's just my input is the entire f function, 2x squared plus 3. So I'll distribute this 4 times 2x squared, 4 times 3. Combine my like terms, and I get 8x squared plus 4. Notice f composed with g and g composed with f are two completely different values. Order does matter when it comes to composition. Now, what does it mean to do f composed with g at a specific value? So I want f composed with g at 1. So that means I want f at g of 1. So whatever g evaluated at 1 is, get that value, and that's what I want you to plug into f. So inside here, we'll find what g at 1 is. So g was 4 times your input minus 8. So 4 times 1 minus 8 gives me negative 4. So now into f, I want to put in negative 4. So f is 2 times your input squared plus 3. So 2 times negative 4 squared plus 3 gives me 2 times 16 plus 3, or 35. Now let's talk about this difference quotient. I know it looks really weird, f of x plus h minus f of x all over h, but this is something that is very important and very valuable in calculus. In the previous exercise video, we did visit this f of x plus h. It is really important. So when I evaluate this for f of x equals x squared minus 3, what I want to do is I want to take f and evaluate it at x plus h. So I'm going to replace this entire x with x plus h. I'm going to do x plus h squared minus 3 minus your entire function, which is this x squared minus 3, and divide that whole thing by h. So here it is. Here's your f of x plus h, where I replaced this input with x plus h. So it's input squared minus 3 minus the original function f of x all over h. Here we will have to square this. This is x plus h times x plus h. Here, I'm subtracting this entire function, so I need to subtract the x squared and subtract the negative 3. So I need to distribute that negative there. So here this becomes x plus h times x plus h, still have a minus 3, becomes a minus x squared, and a minus negative 3, or a plus 3. Everybody in the first group gets multiplied to everybody in the second group, so that's x times x, which is x squared, x times h, which is xh, h times x, which is hx, and h times h, which is h squared. We've previously talked about how these are in fact like terms because x times h is the same thing as h times x. So we have 2xh right here. Now notice this x squared and minus x squared will cancel. This minus 3 and plus 3 will cancel. So when you take this xh plus xh and you get 2xh and that h squared, that's what we're left with. Now notice all the terms in the top have an h in it, so I can factor that h out. And now notice these h's are now going to cancel, and that whole big difference quotient really just simplified into 2x plus h. That's it for now. See you next time.